Today we are going to begin our new unit, and this unit is going to be on quadratics. It's such a long unit that we have split it into two parts, so today we're going to start the quadratic functions unit, part 1. All right, first of all, let's get an idea of what a quadratic function looks like. So anytime I have f of x equal to something with an x squared, where 2 is my highest exponent, that's going to be a quadratic function. So far, you guys have only graphed things that are f of x equals x, which was linear, made a line. So this is going to be a different shape. Let's figure out what shape that's going to be. So I have made a table with some x values, and I'm going to substitute each of those x values in and find the y value that goes with them. So -2 first. And remember, I told you guys to be careful to put those negative numbers in parentheses when you do exponents. -2 times -2, +4. All right, so let's put a dot on -2, +4. Now let's do -1. So I've got -1 squared, -1 times -1, +1. So -1, 1 right here. And now let's do 0. 0 squared, 0 times 0 is 0. I've got that right here. All right, +1. Let's move over into the positives. 1 times 1 is 1. So I've got the 0.11, which is right here. And then 2. 2 squared, 2 times 2 is 4. So let's put a dot right there on 4. And so you can see that I have a shape, unlike a line, which just goes in one direction, I have a shape that goes and then changes direction and starts going back the way it came. So this is what we call a parabola. If I could connect the dots nicely with my finger, that's what you would see right there. You guys connect the dots nicely on your paper, but that's a parabola. And notice that I have arrows here. It goes on and on forever in both directions, but it does have that turning point there in the center. All right, let's get some vocabulary. So first of all, parabola, that's the word I just used. A parabola is the shape of every quadratic function. A parabola can go up like this one, or it can go down like this one, but notice that it has arrows on both ends. No matter if it goes up or down, it goes on and on forever in that same direction. All right, a feature of a parabola that you need to be familiar with is the vertex. So the vertex is the highest or the lowest point on a parabola, and it's where the parabola changes direction. So you can see this vertex would be a maximum, and this vertex would be a minimum, and it's where the graph changes from increasing to decreasing or decreasing to increasing. All right, another feature of a graph you need to be familiar with is axis of symmetry. And the axis of symmetry is a line that cuts the graph directly in the center. So what that looks like is that blue dotted line right there. We call that the axis of symmetry. Very often we're going to abbreviate that, or my pen back on, abbreviate that as AOS. So AOS stands for axis of symmetry if you see that written anywhere. And you can see it's the blue dotted line that goes right directly through the vertex, and it cuts the parabola in half. If we were to fold it over on the axis of symmetry, it would fold right back over on top of itself. All right, now this next one, it's really important that you're familiar with all of these terms: x-intercepts, zeros, solutions, and roots. Very often those are used interchangeably, and what they tell us is where the graph touches or crosses the x-axis. So an x-intercept, you know from the past, where the graph crosses over the x-axis, but those points are where y equals 0, so we sometimes call them zeros. If we take a quadratic equation and set it equal to 0 and solve it, that's the answers that we get, so we call them solutions. And they are also called roots of the polynomial. The roots are the things that create, and it grows from these things. So any of those terms could be used interchangeably, and you need to be familiar with all of them. Okay, so there are 3 forms of a parabola, and we are going to be working with all 3 of those forms. In this first lesson, we're going to focus on vertex form, and then we're going to focus on the other 2 after that. So vertex form gives us a couple of different pieces of information. of course, it gives us the vertex. That's why it's called vertex form. And the vertex is the point HK. So you can see that in the parentheses, it's the opposite of H, and then I have K right here. Well, you remember when we did our translations, the one that was inside the function with X, you did the opposite of, and it's the same thing here, the opposite of H inside the parentheses, and then K just like it is out here. We can also, from this form, find the axis of symmetry. You remember from our picture, the axis of symmetry is a vertical line right through the center. Vertical lines have the form x equals a number, and that number is always going to be the h value of the vertex. So you can see that whatever we find here for h, we're going to use that same value for the axis of symmetry. All right, the next form that we have is intercept form. Notice that vertex form has an A, and intercept form has that same A, only it is written x minus p, x minus q. We're going to learn how to do this over the next couple of days. And this one gives us our x-intercepts. Okay, now look back at what you wrote just a minute ago. What is an synonym of x-intercept? What is a word that means the same thing? Just give me one of those on that list that you have. So the x-intercepts are points. It's where it crosses the x-axis. And remember, on the x-axis, the y value is always 0. So our intercepts are the points P0 and the point Q0. Those are the intercepts, the x-intercepts. So we get those from intercept form. And the last one is called standard form. Y equals ax squared plus bx plus c. And again, you can see that same a that we had here in intercept form and we had here in vertex form. So from standard form, we can find the y-intercept. And do you remember when we found y-intercepts before, we substituted in 0 for x. So if I put in 0 for both my x's, this one is going to become a 0, and this one is going to become a 0. 0 plus 0 plus c is c. So every time the y-intercept is going to be this value. And if you write that as a point, the x value is 0, the y value is c. It's whatever this constant is here on the end. Remember, constant just means a number with no variable. Also from the standard form, we're going to be able to find the vertex. The vertex formula, h equals negative b over 2a. So normally these are all formulas that you need to memorize, and as you move forward in math, you're going to be expected to have these formulas memorized, but it's kind of a lot for right now. So just write it all down there on your sheet, and we will work on it over the course of these next 2 units. Okay, so let's look at a problem here, helping us understand the axis of symmetry a little bit better. So I know that I have a parabola with an axis of symmetry, x equals negative 3. So remember, the axis of symmetry is a vertical line. That's why it's x equals a number. And we are always going to draw the axis of symmetry dotted, because the axis of symmetry is not actually part of the parabola. It's just there to help us draw the parabola better. We need that for our eyes. It's not actually part of the parabola itself. But I do know that this particular parabola has a point 1, 6. So let me put a point right here on 1, 6. Okay, so think about what the axis of symmetry does. It cuts the graph directly in half. If we folded the graph, it would go right over top of itself. So that means if I have a point over here on this side of the axis of symmetry, I should have a corresponding point over here on this side of the axis of symmetry. So let's count. 1, 2, 3, 4 to get to the axis of symmetry. This is a distance of 4. So I need to go 1, 2, 3, 4 on the other side of the axis of symmetry, and I should have a point right here. Now, I don't know anything else about my parabola. I don't know if it opens up or opens down. I just know that it has these 2 points on it. So the x and y coordinates of this point, negative 7, 6. Let me put that as my answer, negative 7, 6. Okay, pause the video right here and draw a sketch of that. I know you don't have a graph in your notes. Just draw a sketch of that in your notes. We're going to need that for the next problem. Okay, in this problem, I have an axis of symmetry at x equals +4. Okay, so what am I going to draw based on what you did last time? What am I going to draw for the axis of symmetry? I'm going to draw a dotted line on x equals 4. All right, you can see my dotted line right there. And I also know that it contains the point 1, -3. So let me put a dot there. 1, -3, right there. Okay, and the directions of this particular problem tell us to find another point on the parabola. All right, well, how far is it from the axis of symmetry to the parabola? I mean, to the point that's on the parabola. 1, 2, 3 units. So if I have a point 3 units to the left, I need a corresponding point 3 units to the right. All right, so I'll count this way. 1, 2, 3. All right, well, you don't have this XY axis on your paper. You're just sketching. So think about this. If you're at 4 and you go 1, 2, 3 units, where do you end up? So I'm really at 4 and I'm moving 3 units to the right. My x value is going to be 7. My x value is going to increase by 3. But my y value is not going to change at all. Do you guys see I'm kind of on a horizontal line right here, moving 3 units to the axis of symmetry, and then 3 units past the axis of symmetry. 4 plus 3 is 7, but my y value did not change. So I have the point 7, -3. All right, and you can see the same thing here. I went 1, 2, 3, 4 units to the axis of symmetry. So if my axis of symmetry is at -3 and I go to the left 4 units, that means I'm subtracting 4. I'm going to end up at -7. -3 minus 4 is -7, which you can see right there. But you can also see that my y value did not change. I just went straight across horizontally right here. So my y value was 6, just like I had before. All right, let's move forward. Okay, so on this one, fill in vertex form from what you had on the other page. And then I want you to write over here in this part of the rectangle, vertex and axis of symmetry. And from what you had on the other page, put in the formula for the vertex and the formula for the axis of symmetry. All right, so for the vertex, remember the vertex is the point HK. And you can see it's the opposite of this one, and then this one just like it is. And the axis of symmetry, remember that's a line equation, so x equals h. If you just put a number here, if you just put 7 or 2, I'm going to mark it wrong because 7 and 2 are really nice numbers, but they are not line equations. The axis of symmetry is a line, so you should have x equals 7 or x equals 2 or whatever that number is that's in the x value, because the x value of the vertex, that h, is where the axis of symmetry is going to go. All right, we will complete the rest of these notes together in class.